Good morning, good afternoon, or is it good evening? I don't know what time it is. It's like early in the morning where I am. What about you? My name is Carl Franklin, and I'm here to talk Blazor. Just about everything I know about Blazor in 2 hours or so. Welcome to the Blazor Roadshow. Before we get started, we really need to thank our sponsor, DevExpress. They've been in the business of making developers more productive for over 20 years. And they started with Delphi controls, believe it or not. And the 5 guys that are using those controls are still supported to this day. Of course, historically, VB, .NET, Windows Forms, ASP.NET Web Forms, MVC, just about every platform that you're interested in, they have tools for. And now they have tools for Blazor. And right now, they're free for you if you just go get them at devexpress.com/freeblazor. I also want to point out three people from DevExpress are in the chat rooms today. First is Don Webier, and he's going to be answering questions that are usually for me about Blazor. He's a Blazor expert and also knows a lot about the DevExpress controls. John Martin from DevExpress is also in the chat room. And John is a great guy. You probably see him if you go to conventions and stuff, like I do, the NDC conference, the Dev Intersection conference. He's there usually doing demos and talking about DevExpress. Also from the land down under, Paul Usher is out there. Hey, Paul. So if you guys have any questions while I'm doing my thing about stuff that I'm showing, just type them in the chat room and one of those guys will get back to you. Sure shooting. So here's the agenda. I'm going to share everything I know about Blazor in a couple hours. As I said, be prepared to drink from the fire hose. However, you don't have to have FOMO, or fear of missing out. Oh, audio issues you can only hear on the left side. Yes, I know what that is. I know. It's just a setting that I didn't set. And now I should be on both sides. So anyway, yeah, I had some new audio gear and stuff, so I had to re-put my input in. You don't need to know what that is. But anyway, you don't have to have fear of missing out or FOMO, because everything that I'm showing you, including a hands-on lab, which tells you how to recreate the software that I'm showing here, is available online at blazordeskshow.com. So if you haven't gone there, please go there. And you can also download the PowerPoint presentation in a PDF format. Okay? Excuse me while I sip my Brazilian breakfast juice. How you guys doing out there today? Tonight, this afternoon? Make some noise if you're in the chat room. Okay, here we go. So what is Blazor? Great place to start. Hopefully you've already been kicking the tires a little bit, but if you haven't, the thing is about Blazor, it started as Steve Sanderson's experiment to write C# code that runs in the browser on WebAssembly, which was fairly new at the time. And I'll talk a little bit more about WebAssembly, but that is what people typically associate Blazor with. But then over the last couple of years, it evolved. It evolved into a component model that can run both. And I got to say this carefully, because the component model, we can have two types of Blazor applications. One is a Blazor server. This is the hosting model, the server-side hosting model, which takes that same code and markup and runs it on the server without modification. And then we also have the Blazor WebAssembly, the client-side model. So they basically created two ways to develop Blazor applications. Now, with the server side, all the code runs on the server. Client side, it runs in the browser. However, it's the same markup in code, and it'll run in either place, but not at the same time. You wouldn't want to merge these two hosting models, nor would you really want to. The reason is it's a SPA framework, right? It's a single-page application UI framework, much like Angular, React, or Vue is with JavaScript. Yes, it uses C#, but the thing is, it's just for UI interactions, right? It's not a framework like it doesn't replace Web API, for example. You still use API calls to get data. This is really just for UI control, right? So it's for binding, for accessing variables and data that you want to show. But and this is something that I really have to iterate, because I get this all the time. Carl, isn't this just the next Silverlight, right? And we're talking about the client side. No, it's not. It's really, really not. And here's why. First of all, a little history lesson for you. Silverlight was a technology that used, yes, it was a cross-platform CLR, but it got into the browser through the plugin model, which is the same way that Flash gets into the browser, or got into the browser. And the plugin model turned out to be insecure. So there was a whole bunch of malware that was written primarily through Flash to get into browsers and infect systems. And Steve Jobs noticed this, and he also noticed that people were complaining that when they watched Flash videos or used Flash on iOS devices, iPads and iPhones, that the battery would run down really fast. So Flash wasn't ideal, but the plugin model was insecure. And so he basically said, all right, on iPads and iPhones, iOS, the operating system there for mobile, no more plugin model support in the Safari browser. And so that was the thing that made Silverlight unattractive for .NET developers. It's not that big bad Microsoft came along and stuck a knife into Silverlight. That didn't happen. Steve Jobs essentially said, no more plugins on iOS, therefore Silverlight won't run on iPhones and iPads. Therefore, why would we want to do this? Because that was the cross-platform goal of the day. Everybody really wanted to write apps that would run on iPhone and iPad without having to learn, all the stuff that you need to do for native applications, which, Xamarin didn't exist back then. So there is the reason why Silverlight isn't used today. Now, the only thing that you can say about WebAssembly and Silverlight, the only thing they have in common is that you can run C# in the browser. But WebAssembly is a little virtual machine that's cross-platform that runs in every major browser, and I'm talking every browser that is currently being updated and worked on and supported. Internet Explorer is one such browser that it doesn't work on, ironically, Internet Explorer coming from Microsoft. But Internet Explorer basically stopped at 11 and then went to Edge. And Edge is the new Internet Explorer on Windows, right? However, some companies still use Internet Explorer 11 with their clients because it supports older things that, such as the plugin model, that they feel doesn't, these companies feel doesn't impact them. So we really want to get everybody off of Internet Explorer 11, but that's not going to happen. Well, anyway, it's WebAssembly isn't in there. So if you're thinking of Blazor for people who are using Internet Explorer 11, you can always use the server model, hosting model with a polyfill, and that'll work. Okay? So Blazor, not Silverlight. WebAssembly is a walled off place where you can run code other than JavaScript with the same security restrictions that JavaScript has. All right, so the only thing different is the language that we can use. It basically opens up browser development to languages other than JavaScript. That's what WebAssembly does, and it's supported by iOS and Safari. Rust runs there, Golang runs there, Python runs there, and now C#. So that's the good news. And that's why it's not Silverlight. And that, sir, is why it is not Silverlight. It's a Frank Sinatra song there. I don't know. All right. If you want to today build a Blazor application with what's in the box, Blazor Server is your only option in the box. But Blazor WebAssembly is in preview. Excuse me. And you can download that. You can get the latest .NET 3.1 SDK. You can use the latest Visual Studio 2019 preview. The free community edition works just fine. And then you can install the WebAssembly template. And this URL right here tells you how to do all that. Or if you just go to, if you just Google Bing Blazor WebAssembly Preview 3, you'll go to that web page that has all those instructions right there. The WebAssembly template is installed at the command line. Okay. What we're going to do is talk about the different hosting models, and we'll compare and contrast them. We'll do some code in Visual Studio, and we'll run them in the browser and see what they do, you know, see what kind of traffic they have and what's going on under the hood. And hopefully you will be able to make a decision as to which model your particular project would be more suited to. And I'm even going to show you a way that you can sort of punt that decision for later by developing both a client Blazor WebAssembly and a Blazor Server app from the same code base at the same time. That's the secret sauce that makes this all happen. So here's the deal with WebAssembly. I'm sorry, with Blazor Server. There's a little bit of magic that happens, and the magic is SignalR. It's WebSockets. So essentially, and I'll show you this code, we'll jump over there in just a second, but WebSockets via SignalR is a way that the browser can maintain a persistent socket connection with the server. Now, this isn't something that you can actually use to communicate with the server. This is just for SignalR, just for Blazor Server. If you want your own SignalR hub, you can always add that. In fact, I do that all the time in a Blazor application. But this is just for the UI. This is just for Blazor. And it basically, in the browser, hooks all the DOM events and then sends requests to the server via SignalR with this one-to-one client-to-server communication line that's persistent. It stays open. And then the server figures out what code to run, runs it, and then the server takes a look at the client's DOM because it has a graph of the DOM in memory right there on the server. And after it runs the code, it gets a diff or figures out how the DOM has changed and then sends messages back to the browser to say, hey, update this element, update that element. And it all just happens seamlessly and there's no plumbing code. So let's actually jump over to excuse me, got a little COVID-19 going here. And I am actually not being facetious. I don't have COVID-19, but I do have the coronavirus. I was tested on March 29th, positive. But I think I got most of the symptoms out of my system now. And hopefully I'm going to have some antibodies that I can share with the world through my blood plasma. Isn't that geeky? Isn't that a nice sentiment for 7 o'clock in the morning on April 15th? No tax day. All right, so what we've done here is created a Blazor application. I'm calling it Blazor Server. There it is right there. I got my zoom ins. I'm calling it Blazor Server. And I get to pick, because I've installed that WebAssembly template, I have the option of making a Blazor WebAssembly application, but I'm going to pick a Blazor Server app. We're just going to run the app right out of the box, the template actually has a nice little demo in it. So I can run this here. And, you know, there are issues with Visual Studio, the latest preview. Sometimes you'll have to run it twice. Sometimes you'll have to rebuild. There are a couple little undocumented features that you'll see from time to time. You know what I just noticed? Because this screen right here is where my Visual Studio is, and yet when I'm looking away on the video. So let me just do something real quick. This is my, I have complete control over what happens here. Watch this. And I'm going to crop out some of this garbage that's over here. And I'll just move myself. There. That makes more sense, doesn't it? Okay. Now here's a Hello World program that is just part of the Blazor template. And you can see that there's a page called counter, and you click this button and it increments a counter. And then we have this thing called fetch data, which illustrates how to go get data from a service. So let's focus on the counter, and I'll go back to Visual Studio here and pull up the counter page. So this is something, this is the canonical demo for Blazor. But essentially, this is mixing markup at the top with code in a code block. And yes, that can be code in a class, and I will show you how to do that later. But for now, you do have to kind of put up with this weird kind of highlighting and stuff if you're accessing code in the page itself. But, you know, it's a trade-off. So here we've got this current count integer defined, and we're displaying that in a one-way binding up here with the Razor syntax, the @ right? So we can just mix that in with text and HTML. And then we've got a regular old HTML button, but instead of onClick without an @ which would mean this is a JavaScript click event, this is an @onClick. And so this says, hey Blazor, when the client clicks on this, I want to run increment count. Now this is running on the server, right? So we should be able to put a breakpoint here. And in the browser, click, and yes, we get a breakpoint. And you can see that current count is 0. I'll let this run. What you don't see is plumbing code, right? If you've done any JavaScript, you know, if you're doing raw HTML, you know that there's stuff that has to happen. I have to have and make an HTTP web request to a URL, to an API. I need to get some data back, and then I need to update my UI. And there's none of that happening. This is the magic of Blazor, and it's just as easy on the client side. But on the server side, there's that particular magic, that moment goes off, and it's like, wow, SignalR is handling all this for me. Let's actually see what that looks like. I'm going to press F12 to pull up the network tools. Make sure the cache is disabled, and I'll turn that on. Now I'm just going to hit Control F5 to refresh the entire page. And take a look at this. Only 161 little K transferred. That's not a whole lot, is it? No, it's not. Well, you know, it's a pretty simple page. But check out this guy right here. _Blazor ID equals blah, 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 blah. That's a WebSocket. This is the SignalR connection. And if we click on that, and here I'll just clear the messages, click the count button, this is what happened. What happened is we got, we clicked that button, a 291 byte message got sent up to the server. The server then said, I got to run that increment count because the user clicked on this button and it says right there, runs increment count, gets the difference in the DOM, sends back a 148 byte message that says, here's what needs to update. The browser updates, and then it sends back a 27 byte message that says, got it, A-OK. So let's look at, do you like that little move? Let's see the Franklin slide, I call that. So, so here's like a nice little graphic that shows you, that SignalR is indeed putting itself in there and making the magic happen for you. Now, if you want to know a little bit more about what's going on under the hood and you want to actually log the traffic and see what those messages are, I did a blog post here at blog.appvnext.com, and it's just logging SignalR traffic in server-side Blazor. And so it shows you how to hook up the logger to SignalR to actually see what's going on there. So let's talk about scaling, because all the code is running on the server. At some point, the server is going to go, I can't support any more clients. So how do we scale that? Well, there's two ways to scale, as you know. You can scale up, which means more power to the server, added memory, added CPU, right? Or you can scale out, which means more servers, like a Kubernetes cluster or something like that. So scaling out requires that you move state outside, everything about that particular client, the data has to be moved outside to some sort of state management. And also SignalR needs to go outside of that one box. And in order to do that, and let me go back here. There's a link coming up here. Oh yeah, no, it's right here. It's actually on this page. If you look at the bottom of the page here, there's a link to scale with Azure SignalR service. And if you follow that link, it's instructions on how to use Azure SignalR service, which is in the cloud, to completely take the SignalR part of Blazor server out of the equation, out of the server itself, and move it out to a service. And that is good stuff. All right, so let's talk about memory first. Memory is probably the biggest constraint that you have in a single server Blazor server application. This is just an ASP.NET Core 3.1 web application, all right? And yes, if you have an existing MVC application, you can just add Blazor pages to it. You can have a mix of them, okay? But for a Blazor page, you're going to have about 85K server memory required just per client, okay? So you have to do the math. Now there are some numbers I'll show you on the next slide where you can kind of get an idea as to how many concurrent clients you can support. But it means that if you're on a single server and you want to make the most of it, you want to get as many clients as you possibly can, you want to be very careful with memory. And by memory, I mean on a page, how much data are you keeping in memory for that client, just for that client, right? So they're collections of objects mostly, right, that are going to take up a lot of memory. Don't load millions of rows into a list box and send it to the client. You don't want to do that. You want to use intelligent controls that do paging and filtering and searching, basically narrow down the set before you show it to the user, and then load only, one page at a time. So this is stuff that shouldn't be new to you if you've done any web development, but I still have to say it, and you have to think about it. Be judicious with memory. Unless, of course, you have only 5 clients, and who cares, right? No problem. So let's talk about WebSockets, because those are also a finite resource. depending on memory and CPU availability. And as I said, if you want to completely remove that, you can do that with Azure SignalR Service. All right, so here is the slide that that I promised you. So this is from Dan Roth's .NET Conf talk in January. And basically, Microsoft did a test to see with a given server configuration how many concurrent clients they could handle in a real application. This isn't a counter-click, so this is a real application where they were, automating, clicking once a second, and they wanted to see at what point and how many clients did the latency go above, after which did the latency go above 200 milliseconds. Meaning, when I click a button, just for a UI response, if it's 200 milliseconds or less, then the brain thinks, I did that. I made that happen, right? So it's natural. If it's more than 200 milliseconds, you're like, what's going on? Is my internet down? My computer busted? I don't know. Is the browser frozen? Right? So if it's over 200 milliseconds, it's like you begin to understand. The brain thinks, this isn't something that I did. This is something that the computer did. See? So 200 milliseconds is that sort of magic sweet spot, after which it becomes tedious to use or difficult or unpleasant, let's say. So here it is with one virtual CPU and 3.5 gigs. They were able to support 5,000 comfortably concurrent clients, comfortably, and still get that latency. If they bump that up to 4 virtual CPUs and 14 gigs of RAM, they were able to get 20,000 concurrent clients. All right. So you might want to think, well, let's just keep it simple, keep it all in one box. We'll just throw some money at the box and scale it up. There you go. Now, this test that they did not use Azure SignalR service. So this is just with the SignalR that's in the box. Just beef it up, support more clients. So let's talk about the upsides and the downsides of this particular server model. The benefits and the downsides. So on the plus side, the download size is small, and therefore things load faster on initialization. You saw it was like 161K, not a whole lot of data. It's very efficient when it comes to bandwidth and data. That's a plus. Also, everything's running on the server. So you have at your disposal every API that you could possibly run on the server. You also have access to resources that you can directly access, like databases and cloud services, storage, everything. Anything that requires a key, anything that requires security for you to access, it's all on the server. You can deal with it, right? If you're in a Blazor WebAssembly application, you have to put all that sensitive code behind an API layer. So it takes twice as long to build a WebAssembly version of an application just because you have that API layer that you have to deal with. That's a huge productivity gain for Blazor Server, that you don't have to do that. You're already on the server. Thin clients are supported, and more importantly, browsers that are older that don't support WebAssembly, like Internet Explorer 11. With a polyfill, you can support Blazor Server. I've even heard some people say that they would develop a WebAssembly version of an application and then host that with a server, so the server can see if the client is Internet Explorer 11, and if it is, route them over to the Blazor server version of it. So that's a backup that you can think about. And also the last point here, and this is important for some people, not for me so much, but the code isn't sent to the browser, so therefore the user can't disassemble it and see all your secrets. Hey, Sparky, come here. Don't put secrets in the browser, okay? That's the answer to that dilemma. I remember you guys remember John and Jeff Cosby is here too. He was our driver and media guy. When we were in New York, and I don't know, maybe that's where I picked up the coronavirus. I don't know. We were in New York, and I was talking on this very slide, and I didn't have that last point in there. Oh no, I did have that last point in there. But somebody in the financial sector, fintech, financial technology, said, well, we don't want our users downloading and snooping and disassembling our code. That's crazy. And I said, well, you have the same issue with JavaScript. And he said, yeah, but we just put all that sensitive code in Node. Yeah, that's right. So what you're doing is only UI code goes in JavaScript, right? And he goes, right. I said, well, it's the same for this. All of the C# that has your sensitive stuff is behind a web API. It's not in the browser, so don't worry about it. Your secret sauce is safe, even if you're doing a WebAssembly application. So it's moot, but I wanted to have that discussion. That's why I put it there. All right, now let's talk about the downsides, or the things that you have to consider that when you're doing a Blazor server application. So a little extra latency, because you have to, for every UI interaction, go back to the server through SignalR, which granted is fast, but it's still added latency. So if your client is in Starbucks with bad Wi-Fi, on a phone or something like that, you can't really guarantee that it's going to be zippy, right? However, if they're your employees and they're either in the office or they're home, chances are their internet connectivity is pretty good. So you might want to think about that. Internet connectivity, if it's slow, it might make the app undesirable to use. Likewise, if it's down, your app isn't usable. You need an internet connection. There's no offline support. You have to have that lifeline to the server for every UI interaction. And that's what I'm talking about, a checkbox. Selected an item in a list box, a button, right? Every time you do that you have an event that hooks that UI interaction, you have to go back to the server. Scalability, I just talked about that. You can scale up by adding memory and CPUs. You can scale out. We haven't talked about that because that's the next slide, state management. Also, remember, an ASP.NET Core server is required just for the UI to host a Blazor application. Chances are, though, you're going to create a Blazor server application that's also going to have your API controllers, your SignalR hubs if you want those, all of the things that you would normally put in a server application. So just one more last look at this particular model before we jump over to the WebAssembly hosting model. Take a look. If you got any other questions, we'll move on to WebAssembly. And it looks like you guys are getting your questions answered by the DevExpress guys, so I'm not all that worried about that. Let's just move on. All right, the Blazor client or Blazor WebAssembly hosting model is very simple compared to all the magic that happens in a Blazor server application with SignalR. However, remember, it's going to be the same code and the same markup. And by the way, that syntax for the component model is completely baked right now. There is some confusion as to, is WebAssembly going to ship in May? May has been a date that's been bandied about. So let me just tell you the timeline for WebAssembly. Right now, the component model itself, the code, is safe. It's not going to change. The component model is being used by Blazor Server, which is shipped with .NET Core 3. So it's in the box. They can't change it. right? That same component model will work with any WebAssembly application you build today. So and WebAssembly is going to ship with .NET 5 in November, okay? So when it ships, the code you write today will run on the final version of WebAssembly. Now, what's different? What's May all about? Well, in May is when they say the plumbing is going to be baked. So there'll be a drop in May. There was just one a couple of weeks ago, but there'll be a drop in May, and the plumbing underneath will be baked. In other words, the way that you know, the things that you do in the startup or the program CS file for WebAssembly will be baked. They won't change. So the applications that you write starting with that drop in May are just going to load up with no problem and run with the running version or the shipping version in November. However, you can right now build that same markup in code, and if there's any changes in May that break the project, you can just create a new project and pull that code in and it's going to run. Okay, I hope I cleared that up. So as I said before, WebAssembly is this little virtual machine that's cross-platform that runs in the browser, and it isn't going away anytime soon. Everybody supports it. Yeah, and baked, what I mean by baked isn't going to change. That's what the word baked means. So, sorry, that's just parlance. So anyway, WebAssembly is not going away. It is in the browsers now. Every browser manufacturer loves it. And wants it just means another way that software can be written for the browser other than JavaScript. And this is good. Show of hands or whoop-de-woo on the chat rooms. How many people love JavaScript? You just love Java. How many people love it? It's like the best language ever. I'll wait for you. Go ahead. All right, well, so here's my experience. First of all, JavaScript, first of all, there's nothing wrong with JavaScript if that's your thing, right? I am not saying that Angular developers and teams need to jump ship and go to Blazor. I'm not saying JavaScript is doomed. I'm saying, first of all, JavaScript is the lingua franca of browsers, and it will always be because it's there everywhere. It's ubiquitous. It runs on the server. It runs on the client. However, JavaScript was written in a weekend by a couple of people that I think it was Mozilla, Netscape, needed a scripting language. And they said, we need a scripting language, go do it. And so it's lacking in some respects. And so much so that guys like Doug Crockford have to write books this big, you know, to pick apart the good parts from the bad parts and how to work around the bad parts. And companies have invested millions of dollars in training people in Angular and, you know, all of these other JavaScript frameworks, but Angular is certainly the big one. And they've invested a lot of time and a lot of money with their teams. And, you know, if you don't want to jump ship and go to C#, do it. That's great. I'm not talking to you. Who I am talking to is the scores, the hundreds of thousands, perhaps millions of enterprise developers who found JavaScript too tweaky, too much plumbing code, and too much effort to keep on top of. Because you've got tribes of packages and package managers and new tools coming out all the time. And just to keep up with those, to make sure that you're using something that is current and working well, and it making you the most productive you can be, is a full-time job. You need a JavaScript czar at your company. You guys probably have one who can just keep on track, keep up with the new technologies and what we should be using and what we shouldn't. All right. That said, you know, enterprise developers who embraced Silverlight have been holding their breath for a long time, begrudgingly using JavaScript where they have to for web applications. But, you know, they'd rather be using, they'd rather be using C#. I know, I've talked to these people. All right. The hosting model is what it is. Let's go back over to Visual Studio. And we're going to add a solution. I'm sorry, we're going to add a new project to the solution. And this will be a Blazor application. And we're going to call this Blazor WASM, because this is going to be a WebAssembly Blazor application. You're going to find the first or the second undocumented feature of Visual Studio 2019 preview. Here it is right here. Where did my WebAssembly template go? Well, it's just a bug, but here's the solution. If you click this drop-down list, you get .NET Core 3 and .NET Core 3.1. Click on .NET Core 3 and then 3.1 again, and boom, your WebAssembly shows up. All right. Now let's look at these options here. ASP.NET Core hosted and progressive web application. Well, progressive web application, you check that, you're going to get the skeleton files for PWA app. And that's a manifest and a service worker and some icons and stuff like that that you can fill out. And when you run this from a website, if you're running on a desktop, you're going to get a little thing in the browser to install it onto your system, and then you can run it as if it was an application. Put it in your start menu and all that. If it's on your phone, it's going to add it to the home screen. So you get a little icon on your home screen, and you can click on that, and it runs without the browser Chrome. I'm talking about Chrome with a little c, not a capital C. So it is essentially a way that you can make something installable, make your app installable on platforms. But not only that, progressive web applications have the ability to cache and serve offline content. So you can store and serve data sets that you would normally use. You could pull those up in your application and use it offline. So we're not going to do that. That is a fairly new feature in Blazor WebAssembly template, just a couple weeks old. But we are going to do this one, ASP.NET Core hosted. And what happens if I don't do this is I'll just get one application which will run in the browser, but I want a server that will serve that application. So that gives the client a place to call home, and it can literally do that. The Blazor WASM server project here that it creates has controllers. So in this particular template demo, there's a shared project also that contains the model weather forecast. So a shared project between the two is a good place where, and it's just a .NET standard library project, this is a good place where you can put models. So the controller can see those models, and the Blazor WASM client, which is going to run in the browser, can also see those models. All right. So having a server to serve it with is a good idea. Not necessary, but it's a good idea. So what we're going to do is set the server as the startup project. That's going to host the client, which will run in the browser. Yeah, let's just run it. Takes a little while to load, doesn't it? All right, but here we go. We have a counter and we have fetch data. First of all, let's go to the counter page as I did before. And notice that with this latest preview, I can actually set a breakpoint, and the breakpoint occurs. But okay, so we do have debugging of a WebAssembly app for the first time in preview 3, but some caveats. Debugging isn't baked completely yet. This is the first round. You can't inspect arrays. You can't step through managed code. There's a few things that you can't do. So it's not quite there yet. However, remember I told you I was going to show you a way that you can put off the decision to use client or server. Well, that same thing allows you to debug client code on the server side. I know. I'll get there. Don't worry. So there it is. Fetch data works a little bit differently on the client because remember I told you when we're on the server, the data's on the server, so we don't need to have an API layer. Here, the weather forecast does have an API layer. So the code is different. Here's fetch data on the server side. And what we're doing is we're injecting this weather forecast service, which is up here in the data folder. And here's our model for the server-side version. And there's the service. And the service is just going to just return some random weather forecast data. All right. So since we're injected, we're just calling forecast service get forecast async, and that's all fine. That is the server-side version of fetch data. The client-side version of fetch data injects an HTTP client, right? And the HTTP client is going to be used to call the API weather forecast. And it's a relative URI because the controller is here in the hosted application, right? So it is the same URL, base URL. There's the weather controller right there. The weather controller is an API controller. And it does the same thing. It returns some random weather data. But notice the architectural differences. We have that extra step because we're running in the client. Okay? Now let's run this again. And we'll pull up the network tools. And we'll take a look at the traffic on this side with a client side version. Here we go. Press F12. I'm just going to expand this here. Disabling the cache. And I'll start recording. And let's go to counter and just press Control F5. So that means anything that was in the cache, we're blowing it away. Just give me everything. All right, let's take a look. 6 megabytes transferred. Uh-oh. Is that too much? Well, first of all, Gmail, 5 megabytes. Has that kept people from using Gmail? No. Yeah, it's kind of annoying, but it can go down even lower than that. And here's why it's 6 megabytes. In debug mode, in preview 3, the linker is turned off. Now, if you set it to release mode, the linker will be turned on. There's also a configuration that you can turn on the linker. When the linker is on, only those parts of the base class library that you're using are sent down to the browser. But it takes a little bit longer to put all that stuff together into MS Core Lib DLL. So that's why the linker's off in debug mode, because you're probably using it on the same machine. And go to release mode, it's going to be less. Let's actually do that. I'll change to release mode. We'll run it again. Yep, takes a little bit more time. And now we have this. We'll press F12 again, disable the cache again, go to counter, press Control F5. And now we see 1.9 megs. That's a little bit better, isn't it? Yeah, a little bit better. So 1.9 megabytes, meaning that I didn't have a whole lot of data to send down. Let's actually sort by size. And we can see what was sent here. So .NET WASM is the biggest file that was sent. That is your CLR. That's your mono-based CLR compiled to WebAssembly. That's why it has the WASM extension. That is a WebAssembly binary. All right, that's the exe file that runs natively in WebAssembly. MS Core Lib is the base class library. Now we got that from like 13 megs before it was compressed or something like that. It was big. Got that down to 518K. And now you've got all the DLLs, JavaScript, right? These are all .NET assemblies. And they have to be .NET Standard 2.0 compatible. But there you go. It's running all of that stuff in the browser. Now, if I click, you don't see any traffic because the code's in the browser. It's running in the browser. But that's the thing, is it's the same code in markup, right? This just doesn't have the SignalR magic that the Blazor server had. So more code has to be loaded up front. Now that is in the browser cache, which is controlled by the user. So if they press Control F5, they're going to take the hit again. Control F5. There it is. Okay. So if they get rid of all the stuff in their cache, they have to take the hit again, etc. So it's a little bit different. So let's talk about the upsides and the downsides of WebAssembly. And let's see what happens here. So on the plus side, yep, your code is going to execute more quickly after it loads. And there isn't that extra hop for every UI interaction because it's all running on the client in the browser. Offline support through PWAs. So if you make a progressive web app, as I said before, you can cache data. That's a whole nother topic. We could do a whole nother desk show on that. You can distribute with a CDN because it doesn't require a server. There might be a server, but there doesn't have to be. I mean, you could have your own API server with your own controllers and stuff, and we can use that from the WebAssembly app. But you don't have to have a server to host it if you don't want to. You can just wrap that up, put it on a CDN, and distribute it, right? And as I said before, any .NET Standard 2.0 C# code will run in the browser. So this is a pretty big deal. On the downsides, gotta get my Gatorade. On the downsides, you have to add that API layer for any sensitive code. It isn't just your database, but databases are the thing that every application needs to access. You have to write an API layer. The debugging still isn't baked. Probably by May it will be there, but we don't know. And as I said, I already gave you the timeline for that. Your code is sent to the client. Again, I don't think this is a big deal as long as you follow the same rules you would with JavaScript, which is the code that's in the browser is only UI code, right? You should be calling an API to do anything sensitive. Don't put your secret sauce in the browser. And, because WebAssembly is in the same security boat as JavaScript, that's the issue there. All right, so one more time, there's the model for WebAssembly, the client side hosting model. All right, let's talk binding. Now, I am not going to sit here and read these slides to you because that would be kind of ridiculous. What I am going to do, though, is I will show you what binding looks like and how to do it. And I have gone back to my Blazor server application as the default or the startup project here. I've gone back to debug mode, and we're going to pull up index.razor, which is the static hello world page right there. I'm going to delete everything, And I'm going to copy a snippet in here for binding. Now I will pull up the browser at the same time that we're running this, and you can see what's going on. So we have this message property, a private string, right? And it's initialized to two-way bound message. We have the one-way binding here, which is the header. And then we've got an input tag, and we're using @bind equals message. It's very simple. A property for the input tag is not specified because the default property is value. So I can specify with bind dash whatever property I want to bind to. I can do that, but since the default is value, I don't need to. Now I'll change this, and as soon as I tab off of this input tag, the onChanged event will occur, and that onChanged event is the DOM event that triggers the UI to update. In other words, that will force whatever in that input tag into the message property. And then the one-way binding takes over from there. So really what I'm going to do is press tab. Boom. All right, so what happened here? That DOM onChanged event occurred, and that's the default event that forces the refresh, if you will, right? That changes the message. Now I can change that event by saying @bind::event equals, and then say on input, which is every keystroke. All right? Nice. You can change the event. That changes the bound object, variable, whatever it is, field. So now as I'm typing this, I can say on every keystroke. Now what's happening, because this is Blazor server, is that on every keystroke, I'm actually going back through SignalR to the server, and it's coming back and updating things, right? So you have to be cognizant of that. But that's what's going on. Now for the first time, we're going to build a component. And components is what Blazor is all about. The component model is how the markup and the code work together. A page is nothing more than a Razor component that has that @page directive at the top for routing. Okay? So it is a component. Everything is a component. I'm going to right-click on the Pages folder, and I'm going to say Add New Razor Component, which is right there in the context menu in the latest preview. So I'll call this component Child Component. Now, yes, you can have pages that host components, and those components can host components. It really is a way that you can componentize your applications. Now, here is another undocumented feature of Visual Studio Preview 3, or whatever we're calling this. This little waiting for IntelliSense to finish. All right, just close the component that you created and reopen it again, and everybody's happy. So here's what this component's going to do. All right, I've got some UI up here, a div, some inline styling. Yes, of course, you can use classes. You can use all the CSS you want to. I'm just showing this because it was easy. Give it a little padding. Give it a background color of light gray. That way we know that it's a component. We can see it. We have this one-way binding to our parent message property. And we have an update message method that is going to do something to change the message. Let's take a look at the code here. So for the first time, we're seeing this parameter. What does that mean? Well, that is a way to expose this property or event or whatever it is to the parent, to the guy who's instantiating the component. All right? And those can be set declaratively when we create and instantiate the component. So here's parent message, which is just a string that we're bound to upstairs. And look at this, event callback. So this is how we define events in the component model. This event is going to be called message changed, and we pass a string to it, through it. When we click on that update message, it's going to change parent message to Blazor, and then it's going to raise the event by calling message change.invoke async and passing parent message. And you can make any method async in Blazor just by saying async task. If it was void before, very easy. Now we can call await on it. All right, so that's the component. Just to recap here, we have a parent message that we're exposing as a parameter and an event. When we click the button, it's going to change that parent message to Blazor and invoke the event, passing the parent message, okay? Now, we'll update this code to instantiate a child component. This is really the only thing that's different about this code now, child component. And look at this, we're doing it all with binding. I don't even have to have an event handler here if it's just for updating a field. So we're binding the parent message property. Remember, with that dash, we can specify what property of the component or the DOM element or whatever it is that we want to bind. We're binding the parent message property to message, okay? Now, look at how we're handling the event. We're setting the event that forces this update to message changed. Follow me? So when the message changed event happens, this message will update to whatever the parent message is, and then this will update, and this will update. Let's run it. And we're still binding on input every keystroke. All right, so check this out. All right, so in the component, because we're bound to the component, that is changing. Now if I change it from within, boom, everywhere it gets changed. Cool, huh? Yeah, binding. Binding good. Now aren't you glad I didn't read that slide to you? I think it's really, really elegant, just to get back to binding, how the component model simplifies event handling and binding and all of that stuff. If anybody has done any Angular, you know, just to get this going in a kind of a hello world situation is difficult. So let's talk about state. Now remember, we talked about scaling. We talked about scaling up by adding memory and CPU. Now we're talking about scaling out. And before you can scale out, you need to move the state, or any of the data that's being displayed in the browser, being accessed by the browser. We need to move that out of the particular server and put it somewhere where we can retrieve it, where we can save it. Now, before we can do that, we have to move it out of the page itself. Let me show you what I mean. So here's that old counter page, right? We have this current count right here as a page variable. Now, not only is it bound to this particular server instance, it's bound to this page. And anytime that I navigate to that page, it's going to reinitialize because it's a page variable. So here's my counter. I'm clicking, I'm updating, right? It's 7 right there. I go to any page and I come back and navigate and it's 0 again. Because every time you navigate to a page, it gets reinitialized, meaning that this goes back to 0. And any state that's in the page is wiped, right? So the first step is to move all of these variables out into another class, whatever they are. And I will do that right now. I'm going to add a class. Call it app state. It doesn't have to be called app state. It can be called whatever you want. And we only have one variable here, one property. I'll call it counter. Now, how are we going to get that in the code? Well, let's go to startup. We're going to add it as a scoped service. And what does that mean? For that matter, what is add singleton and add scoped, and what's the difference? Well, the weather forecast service is added as a singleton, and this is on the Blazor server side, okay? There isn't any difference on the Blazor client side when you do this, all right? Because there isn't this concept of instances per user, right? But a singleton on the Blazor server side means that there's one instance that's shared between all users, right? That's why a weather forecast service, something that just returns data, is a good candidate for a singleton. I want one instance and I want it shared among all users. So in the parlance of web forms, you might think of this as application data, right? It's shared among all users. Whereas scoped services, there's one instance per user. So you might think of this as session scoped if you're thinking in an ASP.NET Web Forms way, right? But that's the difference in Blazor server between singleton and scoped. We want one instance per client, per user. So how do we get that into counter? Well, let's go up here and inject it. Now, oh yeah, I'm a C# developer. I'm used to semicolons. You can use them if you want, but you don't have to, and that kind of drives me nuts. I don't know. What is this world coming to? Okay, so now that I have app state, this injection does not instantiate a new app state, okay? It's injecting whatever the instance policy is, you know, scoped or singleton. It's injecting that instance into this page. And I can inject app state now into every page. And I can access data that's on that page, in the app state. And for the life of my session, for lack of a better word, that data is going to be there. If I refresh it, it's going to go away. So this right here goes away. And now we can use appstate.counter up here as well. All right, now we have our counter. We'll click that button a bunch of times. Now we're actually modifying the app state counter property. I go to another page and I come back, and guess what? It's still there because it's outside the page now. All right, so that's the first step in scaling out. The second step is completely up to you. All right. So unlike web forms, there isn't any sort of opinionated session object that has an infrastructure where you can store the data in, you know, locally in the server or in an app server, a state service running outside, or a SQL server, right? Those aren't your three options. Essentially, they've said, you know what? It's up to you. You now have a variable or an instance of an object that you can serialize and put it wherever you want. So what are some good options for that? Well, the first thing that comes to mind is local storage. And local storage is a protected section of the browser where and there's ways to do this with Blazor. It's easy to do, where you can store data in there. and it's basically a key value system. So you say I want to store with the key, counter data, store this app state thing or whatever it is, or I just call it state, whatever you do. If you want a good example of that, I have this shopping cart app that I wrote, and I was inspired by Steve Sanderson's blog post where he was talking about how to store state in local storage. And I made something that was a little bit more concrete, a little bit more than just a counter. So a shopping cart in this demo, essentially what happens is you add items to your shopping cart with a quantity, and then you get this list of items, right? Like you would mostly do at any online store. And every time you modify that, there's a state provider that is pushing that stuff into local storage. And then there's a timeout. So the default timeout is 30 seconds, just so that you can demo it. Of course, it can be anything, right? So if you close the app, completely close the app, browser app, load it back up again, and it's going to, if you're within 30 seconds, it's going to load up all of that stuff, and the shopping cart will be right there again. So that's one place. Now, the caveat with local storage is you don't want to make that too big, right? You have, I don't know if there's a limit to space, but if you start thinking about all the stuff that you want to put in there, how much performance-wise is it going to be to pull gigantic wads of data out of there, because it has to go back to the server and then it comes to you, right? Yes, it's in the browser, but when you pull from the browser, it goes to the server, then it rehydrates on the server, then you have lists of data, and then it comes back down through SignalR. So if it's a gobs of data, probably not a good idea. So the next level, is some database somewhere. Now, what databases are appropriate? I don't think SQL Server is an appropriate database for storing serialized objects. A document database, like RavenDB or MongoDB, or even on Azure, well, on Azure you have other options, but those document databases are generally cheap, and it's just here, store this blob, right? Store this data. You could use blob storage, but again, that's not going to be as cheap as a document database. Certainly Cosmos DB is going to be your most expensive option, so I wouldn't use that. Just a good document database is fine. So what you do is you hook the sort of on init, or one of the lifecycle events that happens when that page gets initialized, like parameters set or whatever. The user is logged in, right, with authentication. We'll get to that in a minute. So you have their user ID, whatever it is, email or whatever, or GUID, and then you use that to go to your document database and get that state object, rehydrate it, populate it, and now you're good to go. Now you've got your state. And so every time that page loads, you've got everything that you need right there. All right? If it's on a per page basis or if it's for all pages, it doesn't matter. And that could be the last set of data that you were using. It could be values that were put into a form, right? So the big example there is if somebody's filling out a form or a bunch of forms, right? And before they get to the end, something happens. Oh, I got a phone call. Everything times out, and now they have to go back and fill in all those fields again. But if after every field is put in, the state gets updated and gets saved, you've got that data saved. So you can go back in, the forms are filled out, good to go. All right? So if you're going to scale out, you need to do two things. You need to move the state, first of all, out of the page and into some object, and then you need to think about where that's going to be stored and retrieved. And then you also need to use something like Azure SignalR Service. Now remember, we're just talking about Blazor Server here because that's really what needs to scale. The client, not so much. It's one app, it's on the client. Follow me? Okay, I'll give you guys a minute to ask any questions. Looks okay. Looks like Don is answering some good questions in the chat rooms. This is all good. All right, I'm going to show you now what I promised before, which is how to develop a Blazor WebAssembly and a Blazor server application together simultaneously in the same solution with one code base, the client-side code base. And the client-side code base, because it has more requirements, right? You have to use that web API. You couldn't use a server code base because there's, assumptions there that everything's on the server. If you're going to use one code base to run in both hosting models, it has to be the client-side base. So this is a trick that I learned from Steve Sanderson at NDC London this past January. And how it works is that you have the solution set up like we do now, right? Where we've got the server application, right? The Blazor server, and we have the Blazor client and the Blazor WASM server and the Blazor shared. So what I'm going to do is add a reference from the Blazor server project. We'll add a project reference to both Blazor WASM client and Blazor WASM shared. All right, Blazor WASM client is where the code and markup is for the client-side app. Shared is where the models are, so I need access to both of those. Now, once I do that, here's the magic. And before I show you what the magic is, let's just take a look at a little bit of the architecture of these solutions so we know what we're doing here. Under pages in the server side, there's this _host.cshtml. All right, so this is the top level HTML that's going to run in the browser. So you got the head right here with all the links to CSS. That's no big deal. This big div right here is just for handling errors and showing error messages. And then this is the main script for Blazor. That's linked right here. If you want to put your own JavaScript in here, you do it right here. Right? Put your own JavaScript functions in there that you can then call from C#. We'll do that later. So that leaves this guy right here in the body. This app object right here is everything. All your markup, all your code. Okay? Not the JavaScript, but all the markup in the code is represented here. So if I change this to the client-side app, what is it called? Blazor WASM client app. Now, instead of on the server loading our code and markup, we're going to use the Blazor WASM code and markup. Yay. Isn't that awesome? Now, another thing that we have to do is turn off pre-rendering. And to do that, we change the render mode from server pre-rendered to server. And when pre-rendering happens, first when you access and load the page, and load the app, and everything gets pre-rendered, and then again it renders when a client connects to it. So it's a way of sort of jitting, I guess might be a good analogy, although it's not quite the same. So what we've done here is now we've said, hey, when the server app runs, we're going to run the client code, but we're going to run it on the server. And therein lies the issue with debugging, because I can debug client-side code on the server with the full version of Visual Studio and the debugging and all. It works. It works great. But the debugging from client itself is not quite baked yet. All right. So now that I've done that, I'm going to go to my solution properties and run both apps at the same time. So it's going to be multiple startup projects. And I'm going to set Blazor server to start and Blazor WASM server to start. Now I'm going to get two browsers running when I press F5. And you may have to run this twice. You may have to rebuild. I don't know. It depends on how Visual Studio is feeling that day. But here's what happens. We get two browsers that load up here. And I'll put these side by side so we can see the difference. Here's Blazor WASM on the left and Blazor Server on the right. They both say Blazor WASM here because that's in the code and markup. But right up at the top on the tab, you see Blazor WASM over here. You see Blazor Server over here. Okay? So there they are. Now remember, on Blazor Server, we had all that binding stuff in the home page. Yep, that's gone because we're not running the Blazor Server code and markup. Let's see how everything works. Go over to counter in the WASM side. Yeah, that works fine. Fetch data. Yep, it works fine. There should be no difference here. However, remember I told you how fetch data works differently on the client than on the server? Yeah, we're going to have some problems over here. So the counter works fine, but fetch data is going to cause a problem. Now remember I showed you that little error reporting div. That's what's going on right here. An unhandled exception has occurred. See browser dev tools for details. Well, that's if you're running in debug mode. If you're in release mode, it won't say press F12. You know, we're not going to tell the user to check out the browser tools, but we will take a look and see what's going on. All right, right here. Yeah, too wide. The first error is it doesn't understand what HTTP client is. Because remember, HTTP client was injected on the client side, fetch data, so that we could use the API, but not so on the server side. So the server side doesn't even have access to an HTTP client. It's not there. So what we can do is go to Startup. And we'll add HTTP client. And we can then run this again and see if that gets us one step closer. Now, what do you think? Is it going to run? Is it not going to run? Based on what you've seen so far, there might be a clue. Anyone? Bueller? Bueller? Is it going to work? Yeah? No? Yeah? No? No, it's not. And by the way, when we have an unhandled exception, everything stops, right? On the server side, that's by design because we don't, the connection is severed because we don't want the user to be able to use the application if an unhandled exception has occurred because it's in a state, who knows what. Could be used as an attack vector. All of that is by design. But let's take a look at the message now. All right, it's not an absolute URI. It's weather forecast. And we don't know what that is on the server side. In the environment, we don't know what that is. So if we're running this code on the server, and here's the URL. So we need a fully qualified URL. And to get that, we'll go to Blazor WASM server where the controller is, go to my properties and launch settings JSON, and I'll get the SSL port, which is really the only difference in the URL. Go back to fetch data and then fully qualify this. HTTPS colon whack whack localhost colon 44308 weather forecast, and now everything should be hunky dory. Happy, happy, joy, joy, working like a charm. You guys liking this? Isn't this the coolest thing you've ever seen? That's Steve Sanderson, man. He's a brilliant genius and completely just humble and, you know, extremely nice and unassuming. and very approachable. You can go up to him at a conference and say, you know, hey, I just want to tell you this is amazing stuff. And they go, oh, thank you very much. Yeah, it's cool. When I saw this demo, actually, I didn't see it. I was in a 2-day Blazor workshop at NDC London with Steve and Ryan, and I didn't actually get to see the advanced talk that he did when he showed this feature, but Don Wibier was there from Dev Express, and he told me, Carl, you got to see this. So I saw it, and I checked it out, and I said to Steve Sanderson, I said, where's the blog post, right? Where's the white paper? This is so cool. And he said, no, it's just a little thing in my GitHub repo. And he pointed me and highlighted the line where you were making the reference to the web, the client app. And that was it. Just an unassuming genius, this guy is. All right, so you saw both of those things worked, and everything's cool there. So let's move on to Band Booker. I'm going to show you an application where we're going to learn about code behind, validation, JavaScript interop, and generic components. So this came as a necessity because I play in a band and there's 10 people in the band. And trying to get 10 people together for rehearsal is like herding cats as it is. Try to get them saying yes to a gig. It's kind of impossible. So I wrote this application because typically what happens is I'll get contacted by a venue that says, you know, here are the dates that we have for this month. Can you guys play? When can you do it? And I'll have to email all the band members and, you know, hound them for weeks sometimes. There was one instance where by the time everybody answered yes, they had already booked another band. So I needed something quicker, right? So that's what this application is. It allows people the band members to go in and say yes to a gig or no to a gig. It hounds them by email and continues to hound them until they go and specify that they can play it or not. And once they can, the admin, me, gets notification that the positions have been filled. I go and book it and everything's good. So this is essentially my 2-day workshop for NDC. And right now there's a sort of the older version of it before this last preview is online at blazor.appvnext.com. So if you want to see the full version, at least in the older version, you know what I'm saying, in the older preview, there it is. But after NDC Porto, I'm going to record that video and change all that stuff. So you might want to wait on that. But we just have a demo that has 2 models, instruments and musicians, and we can manage both. Now also, I'm going to show you ASP.NET Core identity-based authentication, which I got from Chris Sainty, who's a really smart guy, and sanctioned me to use his code in Band Booker. He has a blog post right here to show you how to do JOT token-based authentication with WebAssembly and building out your own UI for it and everything. You get complete control over it. So that's what we're going to do. Uses API controllers for the authentication to register and to log in. Those pass back JOT tokens, which are just JSON web tokens that contain the claims and all the creds and all that stuff. Store those in local storage, and you're good to go. So those are the things that I'm gonna be showing you. So over here, I will load up Band Booker. And is that the one, or is this the one? Yeah, this is the one right here. All right. So I'll first run it, and I'll show you that, yes, I am using the same technique as to building out both the server-side and client-side versions at the same time. And first of all, you can see I've got authentication, and authorization also is really easy with Blazor, and that's actually going to be the first thing that I show you. And yeah, I'm getting an error here. This just happens because sometimes you just have to build the solution, rebuild the solution, run it again. I don't think that's an actual error in my code. No. All right, so this WASM version, I'm not logged in, and I see, please register or log in to use this app. All right, so here's authorization. And the only rule is I have to be logged in to use it. There are role-based authorization, which you can use in Blazor, but this demo doesn't cover that. So if I'm not logged in, I see please register or log in. This register page, I built that page with me bare hands, stone by stone. No, sorry. And the login page also. But I'm just going to go back and use the band booker one over here. All right, so we have a list of instruments. We have a list of musicians. Let's use this one. So notice that my edit and delete buttons are disabled until I select an instrument or a musician. It's the same thing, and I've got my CRUD buttons here for new, edit, and delete. If I press new for a new instrument, notice that, first of all, this is a component in the Carl Franklin Battleship Gray here, just to show you that it is a component and not the same as the index page. And notice also that we have a blinking caret, meaning it has focus. I use JavaScript interop for that, because there isn't a focus built into the component model just yet. It sounds like they're going to have that in there before it goes live, though. So if I add something here and I go over 50 characters, I'm going to get name is too long here. This is the validation stuff. I have a rule that says maximum length is 50 characters. I also have a rule that says it's required. Name is a required field. And so it's not even allowing me to press add until I satisfy those validation requirements. If I do edit here, it's highlighted as well as selected. So here's keyboard, and I'll update that. Very good. And I can delete, no sweat. Coming over here to musicians, here's Piano Patty. I'll edit Piano Patty. We have a name field. And then this right here is a way to select instruments. This is using the generic component technique. So this is a generic component. And because I have specified instruments as my list of things, it understands what an instrument is. And I've specified the name property as being the text property or what to show. And I've specified the instrument ID property or the ID property as the value, right? So let's say I select keyboard. You've probably seen this UI before a million times, right? Where you have the option to select from a list, a master list, and then the selected list. And the object can only exist in one place or the other. So that's pretty much it. It's simple, and yet it's done right. So let's look at index. This is index razor right here. Authorized view. So authorized view means I have an authorized and a not authorized section. And in the authorized section, that's what happens when if I am authorized, if I'm logged in. You can go so far as to define roles with this. Again, that's outside the scope. So this is just the markup. The code is in a code behind or a class. And to do that with any page, you basically create a CS file that has the same name as the Razor component or page. And then you have to make it a partial class, otherwise you'd have to rename it. and inherit from component base, which is right up here, Microsoft ASP.NET Core Components, component base. Also, methods and fields that you access from the markup have to be protected, at least. They can be public as well, but they can't be private. So that's it for code behind. Let's take a look at some of the code in here. I've got a list of instruments, a list box, which in HTML land is a select. Size equals 10 means that it's not a drop-down list if it's greater than 1 or 0. And it defines that I have 10 items to show right there. I have an on change, which happens when I click the select, and that's instrument selected. And the reason I do that is because I want to set a selected instrument variable. And the selected instrument variable is going to be used for editing and updating and deleting, right? So after I have a selected instrument, let's say, I'm displaying all of these items with code here. So for each var instrument and instruments, and that's my master list. And if it's the selected instrument, then I'm specifying an option with the selected attribute. Otherwise, I'm not. That's all that is. And in each option, I have the value set to the ID, and the text is the name. So that's how you display items from a list. And this is just a list of instruments. Now I have some buttons, new, edit, and delete. I can enable or disable them by setting the disabled attribute to a Boolean that I'm binding to. Pretty cool. Here's how we define a component, and as I showed you the child component earlier. But notice I have this @ref equals instrument editor. And that is a variable of type instrument editor, except that it's camel cased. And that allows me to use that reference to call methods or otherwise access that component instance. So that's how you do it with ref. Let's actually look in the instrument editor. And you can see all of the stuff for validation here, starting with edit form. We'll talk about JavaScript interop in a sec, but let's start with edit form. So if I'm doing validation, I need to wrap all of my fields in an edit form, and that is a Blazor component. The model tells it what data we're actually editing, and this is edit instrument, which is a variable of type instrument. And then on valid submit is where I should call when all the validation passes and you press the submit button. Now that's why you don't just have a on click for the submit button, because it has to go through the validation process. And you notice that it wouldn't even let me add or update if I didn't pass validation. So data annotations validator basically means look at the model for the validation rules. So let's go down here to the instrument model. And you can see I have two rules that I'm specifying with data annotations. One is that the name property is required, and the other one is that the maximum length is 50. And I even got an error message right there, right in the model. The validation summary shows what all the problems are with validation, if anything. That was those red error messages that come up. I can put those anywhere, or I can put individual validation messages, wherever I want to, next to the field that they're validating. So next is input text. What is that? Well, it's a validation aware version of this input. Okay. So this is the same as using an input, except it understands validation. And I'm binding that to my instrument name. And now I have my submit button. The only other thing I want to mention is that if you have buttons in the edit form that aren't submit buttons, you have to specify type equals button, standard HTML stuff. Okay, now let's talk about validation. I have this ID specified here, instrument.name, for my instrument name. To use JavaScript interop, I've got to inject an IJS runtime object in there. So let's see what happens when we click the new instrument button. I'm calling instrument editor.new instrument. That's why I had that ref right there. And now getting back into instrument editor, new instrument sets some stuff here like the Boolean adding equals true, whereas if we're editing, it's false. The submit button text, which goes in the submit button right there, is going to be add, whereas it would be update if we were editing. The edit instrument is the new instrument. And I'm setting show instrument panel to true, and that's a Boolean that when it is true shows the component UI. This is how it can be shown and hidden, just with a Boolean if statement. And then I'm calling this JavaScript set focus method, passing the ID of that input text, instrument.name. So let's find out where that stuff is. Well, it's actually in two places. And yes, this is not markup and code. So it's running in the browser in the environment that the Blazor code is hosted in. So JavaScript has to be in two places. Let's go to the server. It's in that underscore host CSHTML that I showed you before. Here it is right here. Now on the client, in Bandbook or WASM client, it's going to be under www.root index HTML right there. That's where JavaScript goes in the client. But it's the same JavaScript. Interestingly, because the JavaScript that you write here is running in the environment, this is an opportunity for you if you want to know which environment you're running in. You can make a function, where am I? And on the server side, you return server. And on the client side, you return client. And then your code can invoke that, get the value from it. And even though it's running in different places, it will be able to tell you where it's running from. So it's just a little trick. And I had to use that once. So, stupid JavaScript tricks, set focus. Why? Why all this stuff right here? Well, it's a typical curse of SPA development that UI elements sometimes don't exist in the DOM until after they've been rendered, and that is what's occurring here. So going back to instrument editor, when I call set focus, right? By the time I'm doing this, yes, my show instrument panel is true, but this has to exit and the page has to be re-rendered in order for this to this guy to even show up. So when I'm calling the JavaScript, he doesn't exist yet. So this is how I solve that problem. I have a function called internal focus, and I'm setting a timeout of 10 milliseconds, calling that, trying to get an element reference. If I don't get an element reference, I call myself again in 10 milliseconds and exit. All right. But if I do, then it falls down to focus and select. Now, you might be asking, well, you might know this, you might not know this, but there are methods on a component that are virtual that you can override. And one of them is called onRender, onAfterRender. All right. And onAfterRender happens after the page is rendered. So you might be thinking to yourself, well, that might be a good place to call set focus. But the problem is, this is going to happen every time the page is rendered, which on the server side anyway is every time, actually on the client side too. Every time you make a change, every character you type, it's going to render. So now I'm going to have to do all sorts of logic in here to determine when I should call set focus or not. And you know what? That's That's not a good solution. This is the solution. All right. How long will it take? 100 milliseconds? A second? I don't know. But it's still not going to, it's not going to wear out my stack. You know, it's going to happen pretty instantly. So there's JavaScript interop. Let's talk about the musician editor, which contains that generic object picker object component. So I've got an all items property, which I'm passing to passing all instruments, my list of all instruments. The selected items, which I'm passing the musician's instruments, or those that the musician has. And a musician, looking at the models here, just has an ID and a list of instruments. All right, so it's pretty simple. So now my item type and item type plural are just strings that I can use for UI, where it says selected instruments and all instruments. The text property is the name property, so that's what I'm going to display. The value property is the ID property. So that's all I have to do in order to show that. Let's look at object picker, and you'll see what it is. Now, most components that are third-party components that you're going to be able to reuse in multiple projects have to be generic, right? In other words, like the instrument editor knows that it's an instrument for an instrument, but this doesn't matter what you pass into it. And the reason I did it this way is because in the band UI, right, where I have a band and I define that, a band has a list of musicians. So I want to use the same picker for musicians that I use for instruments here. This right there is the secret sauce for a generic component. Type param t item. You can call that whatever you want to, but now t item becomes instrument when, as soon as I pass a parameter, right? Like all items is a list of instrument, t item becomes instrument. So here's my selected items, and I even have a private selected item that I've defined as t item. So that's going to be an instrument. How do I get data out of it? I have a couple of helpers. Because remember, I have the name property and the value property. Well, here's an item value helper and an item text helper, which this is the same logic as I used to show the list of whatever it is, the specific list. But now I'm getting the value in the text from these. And right there, I'm just using a little reflection. Because I have the value property name and the text property name, I can read the values of those properties with reflection. So, code behind, let's see what my list is here. Code behind validation, JavaScript interop, generic components. There you go. Authorization, authentication. I showed you a little bit of the authorization, not a whole lot for the authentication. Suffice it to say, there's a login controller and for logging in, an accounts controller for registering. And there's a bit of stuff here that I don't want to go into, but it returns a security, the JOT security token as part of the login result. There it is. There's the token. Now on the client side, when I'm calling this, I have an auth service. Here's the register call. Here's the login call. Yes, I have my variables in there for URLs. That's a no-no, but configuration is possible too. And I'm storing in local storage that auth token. Okay. And then I also have a provider which will load that stuff, get the authentication state from local storage, and it will also mark the user as authenticated and marked it as logged out. Then I have my login page, which, guess what? It has an edit form in there for the login model. And I just call my auth service login, and if I'm successful, I go to the main page. And then if I'm successful, I'm authorized, and the authorized view takes over for authorization. And that's about all I want to say about that. So if you're deploying a Blazor server application to Azure, need to enable WebSockets. This is really only an issue if you're not using Visual Studio to create your app service. If you are, then Visual Studio will say, hey, I notice you're using SignalR. You should enable WebSockets. Do you want to enable that now? And you can press yes, and it all happens from within Visual Studio, and that's easy. But if you've already got an app service created and you pull in that profile in Visual Studio, you need to go into the app service properties, into the configuration, and enable WebSockets. Okay? Now, I want to talk a little bit about DevExpress free Blazor components. Obviously, DevExpress is the whole reason that I'm able to bring this stuff to you. And it was really a win-win for me and for DevExpress to do this, because for me, I want to teach Blazor. I want to get everybody figuring out what Blazor means, what it is, how to choose the hosting model, how to write code for it, what are the upsides and downsides. That's what we've gone through. And just to educate you about Blazor. The second thing is that DevExpress wants to and has a history of creating components that are usually things you don't want to write yourself, right? So their tools are for developers who want to get stuff done. Been in business for a long time, as I said before, and they're very loyal to their customers. And still to this day, as I said, they support older controls for older platforms that don't even exist anymore. They still support those controls. So they're all about maximum productivity. So the win for them is, after I've shown you all this crazy code, now I'm going to show you some DevExpress components, and we're actually going to see how little effort is the wrong thing, but you know, the difference in the amount of code that you have to write to use DevExpress controls versus doing it yourself. That's what they really want to illustrate here. So I'll go back to, I'll go to the browser here at devexpress.com, and I'm going to click on the Blazor demos. I'm just going to pick, charts, pivot grids, tree view, data editors, data grid. The scheduler is the coolest thing. I got to show you this, because this is like dropping Google Calendar right into your project. Look at this. I've got drag and drop. This is in the browser now. I can create new appointments, and I can move them around. Here's one right up here. I'm going to have coffee. That's probably going to have to be a little bit bigger. As I said before, I can drag from one day to another. I can move things around. I can create. I can delete very, very simply. Now, here's the best part about this. Look at what's required in order to make this happen. That is just so cool. That I didn't have to write any of that code. And that's what DevExpress is all about here, is just take advantage of the code that we've already written, and you don't have to jump through hoops to do some amazing things. Now, I'm going to show you a version of Band Booker that Don Weavier actually wrote. And I basically wanted a version that uses the DevExpress grids to do the same CRUD operations that I'm doing with all that select code and everything else. And so here's my list of instruments, my list of musicians. I can create a new instrument. I'll make that conga. I'll update that. That adds to the list. I can delete an instrument. I can edit an instrument. There it is. So now musicians. I can create a new musician. My conga player, my percussionist's name is Che. Now I can click on this list and I get a drop down, and you get this nice little list of things that, instruments that this person plays. Now I can update that. I can edit. No, he's only Conga player. So put that back in. Of course, I can delete. There you go. CRUD operations doing the same thing that I was doing in Band Booker, just with the grids. Now here's the cool part about it. Here's the markup for the instruments. Here's the markup for musicians, which is a little more involved because I've got an edit form, a template right in there for each one. Here's the code for musicians, just essentially it's just CRUD code. And here's the CRUD code for musicians. Right? There it is. Very, very cool. Now, DevExpress also has some things, some sort of primitives that Blazor doesn't support currently. So check this out. I wanted a multi-select list box. So I've got this demo app here called my Coronavirus Shutdown Reading List, and it has some books that I want to read. And here's a single select version of it. Practical Snow Melting for Fun and Profit, right? How to Shave a Cat, something that we all need to learn at some point in our adult lives. And Winning at Tic-Tac-Toe, because I want to show my bratty kids who's boss. All right, so this is a single select list box. If I hit Control, I don't get multi-select, but that's what I want. And you might expect that I could just go multiple here like I can do in HTML. And my onChange would happen. Here's my onChange, book selected. You would think that the args would pass a value that has all of the items, not just the last item that was clicked, but that's not the case. It only passes the value of the item that was last clicked, whether or not you held down the Control key or the Shift key. And now you can see I've got, if a selected book is null, I'm showing the book title and the description here. Now, I went searching through the internets and I found this blog post from a guy. Tell you the truth, I don't know if it was a guy or a girl. I'm just saying a guy because I don't know. So this is shamelessly stolen from this person, AshKE98 on medium.com. Here's the blog post. It's right here in the code, which you can download right now at Blazor-show.com. And so this is a multi-select list box that this guy built. All right. So a whole bunch of parameters. It's a generic component. As you can see, there's the type param. And JavaScript is what makes this possible. Take a look at this. So he's got an on after render async right there. He's got an on change. And he's also got this JS invocable on option select. That means this can be invoked from JavaScript. But it's quite a lot of code. And if you take a look at the JavaScript itself, here it is. So here's our drop down, 3 levels of if statements, a lot of cyclomatic complexity here, but it works, right? He's getting the elements, he's getting select values, and then he's calling with this .NET object invoke method async. So he's actually calling C# code from JavaScript, which is the other side of JavaScript interop. So yeah, quite a lot of code, but if you see in this example, it actually does work. But this is doing it the hard way. Right? I'm pressing down Control. I hold this down, press Shift. I get them all. There you go. But look at all the effort that's required just to give you something that should be plumbing in the box. Right? Well, now what I'm going to do is bring on my friend Don Webier, who is going to show us the easy way to do this using DevExpress controls. Take it away, Don.
Hey Carl, that
Hey.
was a decent amount of work getting that multi-select feature enabled. But fortunately, there are easier ways of doing so by using the native DevExpress Blazor controls. And let me show you how simple that works.
Okay.
I have this page over here and I have only prepared this property which will hold the selected books of the list box. And what I'm going to do, I'm going to insert the DevExpress list box here where I will bind the data to the book service, and I'll specify a text field name, which will be in this case the property name, which will be displayed inside the list box.
Okay.
And then the last thing is I'm going to bind the selected items of the list box to the selected books property of the page. And this is basically all we need right now. Let me also include the code that you've seen before. There is one difference though, and that is instead of cycling through this list with IDs and stuff, you can now cycle directly through the selected books collection. And you can write out those property names straight away. So it's again a bit less code here. And once I run the application, let's see what happens now. If I go to the DevExpress demo, what we'll see is that we have the same UI as we had on the previous pages.
Yeah.
The only thing right now is that if I hold down the Shift key or the Control key, it still selects one. Well, and that's actually quite simple solved, because right now the list box is in single selection mode. If I go back to the code and I'll add a property which I will change to the list box selection mode multiple, we're all set. So let's run a demo again, and I will now be using my Control and my Shift key as well. And what you'll see is I can select items individually or deselect them, or I can even hold the Shift key to select the whole batch.
Very
So
cool.
that's quite simple, huh?
Yeah.
And there is one more thing I'd like to show, and that is setting another property. And that property is going to be show checkboxes. I'm going to put it to true, and now all of you may guess what this will do. So let's run it again, and what we have now is a really nice list box with checkboxes. And for single selections I don't even need to hold down the Control key, but I can still use the Shift key if I want. So if I want to select the whole batch, I'll just hold down the Shift. So a very nice and powerful control.
Yeah.
And yeah, if we check the amount of code that was needed to get this desired UI, I would say this is too much, right?
No, that's great, Don. Thank you very much for sharing that with us today.
You're welcome, Carl, and we'll talk later.
All right.
Bye.
Bye-bye. So there's a couple of ways that you can run DevExpress Blazor demos. You can just go online like I did with the scheduler demo and run that there. Or you can go to this GitHub repo and download the code and run it locally, which is kind of cool. There's a demo there for large data sets, essentially, that you can run locally with your own huge data set. It does all the paging and virtualizing for you, for example. So when you register, and we'd like you to go register right now because this is cool stuff, go to devexpress.com/freeblazor. And what's going to happen is it's going to give you a URL for a private NuGet feed, which you can configure in Visual Studio. Shows you how to do that. Then you go get the NuGet packages, you add the CSS link, and you import the using statement, devexpress.blazor, and you're off to the races. And Blazor roadmap and blogs and all that stuff, they exist at devexpress.com. Just go up there to keep in touch and learn about the latest things that the team is doing. There's going to be a new drop here coming in April from what I understand, and I'm looking forward to that. And get in touch. Blazor Roadshow at devexpress.com or just Blazor at devexpress.com. And that will get you there. So go get your controls. And I wanted to just thank everybody. Thank Don and thank John and Paul, the DevExpress guys that are out there. And thank you for watching. As I've been doing these road shows and desk shows, and it's been a lot of fun, and we're getting a lot of great interest in Blazor. So thank you for watching. And hey, you know what? We'll see you out there, out in the fray. Go write some code. I'm Carl Franklin. Thanks very much for watching.